I read it just a second. Yeah.
Okay, so notes 1618 reviews a little bit of stuff that we've already had, so I'm just getting that back up there for you. So the Pythagorean theorem is a squared plus b squared equals c squared. So the one that really matters which one's which is the c. Okay, so c is always, and that's why I have it labeled there in case you don't remember from the last time, c is always a hypotenuse, and that's the longest side of the right triangle. Okay, so it's always opposite. That's why I didn't do that. It's always opposite of the right angle. That's always the c. So these, it doesn't matter which one is the A or the B. So that's why I put A or B, because it doesn't matter which one you put where. Okay, the only one that really matters is the C. Okay, so this could be A, this one could be B. You don't have to write it. Okay, it could be the A or the B or the A or the B. The one that matters is the C. Okay, then the next one, can I scoot it down a little bit? Nobody's writing that very top. Okay, so the next one is interior angles, so on triangles. So all triangles add to equal 180. So hopefully you can recall that from before. So we're going to have some sections where you have to solve for the sides, some where you're going to have to solve for the angles. Okay, so they might give you two of the inside angles and you're finding the third one, so you would add the two, subtract from 180 to find the missing one. Okay. So we're just going to write a couple of review things and then we'll do some problems. Okay, so the next one, exterior angle for triangles. Exterior angle triangle sum. It's a theorem. You don't need to write the word theorem. So I don't know how many of you remember this from last year, those that were in my class. When we cut out, we had polygons, not just triangles, we had polygons, and we had to cut out these pie pieces and you had to put them together on the paper for the notes. And exterior angles, it doesn't matter what the shape is, exterior angles always add to equal 360. Okay, we're just going to be working with triangles, not the other polygons, just triangles. Okay, so what is happening, and I do want you to draw the examples. What is happening is, so this was a equilateral, equal angular triangle, okay, and we had a 60, 60, 60 that adds to equal 180, okay? What they're talking about is when you extend this, okay, this angle right here, okay, this angle plus this angle plus this angle should add to equal 360, okay? There's a couple of ways that you can find it out. It depends on what they gave you, okay? So this right here, these two angles put together make a straight line. So it means the two of these should add to equal what? 180. So that would mean that this is 120, right? So same thing here, when this extends on, these two angles add to equal 180. So I can subtract that, which would make it 120. And I know these are all going to be the same because the inside angles are all the same. So if you were to add those three, they give you 360. Okay, so another example over here, just because it's different than that one where I made them all the same. So this one would be 140, right? Because the two of them next to together add to equal 180. Well, this one's the same as this one, so this would be 140. What would this one be? 80. Okay, so if you were to add all of those, okay, you're going to get 360, right? Because 140 and 140 give you 280, and then add another 80. Okay with that? Okay. So now, I think there's only a couple more. The one that's next to the 100, because they should add to equal 180, because they're on a straight line. Okay. Writing that, we're going to fill in a couple of more things, and then we're done with the vocab. Okay, we good? Okay, so review from our previous section that we had. What type, if not, don't look at the angles part, the angles question. Just the drawing with the tick marks on the sides. What type of triangle is that? When two sides, isosceles. So when two sides are the same, what do we know about its angles? They're the same. Okay, so there's going to be some questions in this section where it doesn't make it quite as obvious, but if you look at like the sides being marked, or like if it's all three sides are the same, then you're going to know what's about the angles. Because sometimes they only put one, and you're thinking, well, I need two of them to add to equal 180. So they'll tell you one of them up here, and they only want this one here. Okay. So if this was 60 up here, which was not going to make the case work down here, but if this was 60 up here, I would know that these two, because these two are the same size, that these two angles would be the same. Okay. So how would I find these two if I know they're the same? If that was 60, go 60 minus 180, and then divide it by 2. Okay, so they won't make them quite as obvious where you have like maybe a 60 here and a 40 here, and then you're able to find it. As you add and subtract by 2, you need to know what you know about those triangles. Okay, so remember that from the previous section. Okay, so that's why that was up there. Okay, so triangle exterior angle theorem. Okay, means that the sum of, and I don't know if you remember this from last year, when we talk about remotes, we don't use a remote for something that's right next to us. Okay, hopefully, I don't know, some of you might. Okay, we use a remote to reach something that's across the room, right? To get it to work, to turn the TV on. Okay, so triangle exterior angle theorem. Sum of two remote interior angles is equal to the exterior angle. So this is the example. If we know these two, okay, if we add these two together, that's what the answer to that one is. Okay, so you don't have to, because it would save you some steps. Otherwise, you would go this one plus this one, subtract from 180, that would give you this one, okay? And then from there, you would subtract this from what? Because it's a straight line. What's a straight line? 180. Okay, so if you added those two and subtracted from 180, you would get this one. And then you can subtract this one from 180 to get that one. So that's a long process to get it there. So if you notice that they gave you the remote ones and you're supposed to answer this one out here, as long as it's not right next to it, you just add these two together. And when you add these two together, that's what that question mark is. Okay? So exterior angle theorem is a remote interior, means the two that are on the inside add equal what the outside angle is. Okay? So they're going to go back and forth between inside and outside angles. Okay, so we're actually going to do one now. Okay, so this is number 79. And we'll return back to the middle by 4. Okay, so this will be the one, you had ones like this on your con before, where you're not answering whether or not it's the cube, the twos are right. You're actually solving for the missing side. Okay, so which one in your right triangle that I said mattered? Which one was which? The C, right? So this doesn't matter which one's the A or the D. This for sure has to be the C, okay, because it's the one that's opposite, okay? So for sure, I have to know that one is my C. Okay, these, it doesn't matter which one's the A or the B, okay? But I know I'm supposed to square it, right? And square it. Okay, so we would have 13 times 13, which gives me oh my god, YouTube short. X squared. Okay, 5 squared is 25. Now what do I do to solve for x?
Subtract the 25.
Okay, so I'm going to subtract the 25 from the other side so we can get rid of that secret number. Okay, x squared equals 144. Okay, now they want to know what x is. So we don't have x yet because it's still squared. So the opposite of squared is to take the square root. Okay? Square root gets rid of the square, but what I do to one side, I've got to do to the other side to get the x So 144 is 12.
12.
Okay, so x is equal to 12. Okay, so you've had practice of this on your con before. Okay, so that's solving for the sides. Okay, so we'll just go straight on to number 80. This one didn't have a drawing, but it tells you it's a triangle. Okay, so number 80. So I'm not going to write out the sentence. We're going to draw the triangle. It's not drawn on your paper, but we're going to draw. Okay, so it's triangle ABC. So we're just going to draw some random triangle ABC. Just so we can know what we're doing. I don't know what kind of triangle it is. It says the measure of angle A is 13. The measure of angle C is 21. They want you to calculate the measure of angle B. So what would I do?
Add the two together.
Add the two together and subtract from 180. So my calculator people. So we have 13 plus 21. Syntax error.
46.
I know, it's a step.
We were adding 13.
Which is 34, right.
Yeah.
But then you subtract 34 from 180. So add these two, which gave us 36, wasn't it?
And 33.
34, yes. Okay, subtract from 180, okay, and that's what that angle is up there, so that's going to be. Okay, almost done. 81. Okay, so 81. Okay, so this is on the outside of the triangle, not on the inside of the triangle. So similar, but not the same numbers. I'm going to do what with 98 and 123? Add them, and then subtract that from what? 360.
Wait, what do you do? Sorry.
Exterior angles, add all exterior angles, add to equal 360.
So you
So
just
add the two and then subtract from 360 instead of 180. Okay, I think this is the last one. We're going to do a rectangle one because they have you divide the rectangle just so you know what you're doing. Yep. Okay, so 86. So, I'll do it. Okay, so 86, and again, this is a sentence. There's not a drawing for you. So it says a rectangle, again, we're pretending like the board does not draw, has a length of 18 and a width of 13. So it really doesn't matter which one's first. Just one of them's 18 and one of them's 13. Okay, they want you to find the length of its diagonal. What are we finding? What did I just create? What type of triangle?
Right.
Or right triangle. Okay, so we're finding what letter? C, because the diagonal is going to be the one that is opposite, regardless if you came from this other way, went from this way, right? This is still opposite of the right angle. Okay, so here's your right angle on a rectangle, so that's your C. Okay, so you're going to square 13, square 18, because we're trying to find out what the diagonal is. Okay? So we're going 13, again, times 13. Why? You guys better have that number memorized. Oh, you lost. 18 times 18. Okay, so we add those two numbers together.
493.
You got 493 too? Okay, so just type it in something. So then we got to take the square root and the square root of this one, and I don't know. No, I don't. I just don't know if they do decimal or if they have you break it down. Let me check. Hold on.
We don't have to break that down.
Okay, so they have, so I'm assuming on all of yours they'll be that way. They have that, and then they have this written after it, which means approximate, like they rounded to 22.2. Like they have both. So
Okay.
just so you have them both there. I don't think there's any squares that come out of it either. So okay,
So it's like either way of it.
yeah. I'm hoping so they have both answers on all the keys, so when I read them, they're both there, but what? 22.2. If you actually hit the square root thing on your calculator. And that just means approximate, like it went further than that, but they didn't. Okay,